Hi, this is a Turner fluorometer. It's quite old machine, but we can use it to illustrate the way that fluorometers work. So this system has a light source here, which is on, and then it has an emission filter here, which is for chlorophyll. It's set to a blue wavelength. And then we have I'm sorry, that's an excitation filter. This is the emission filter, so the light going out, and it is a little bit red in color, and it actually tunes into the exact wavelength that chlorophyll fluoresces at, so you don't have to worry about correcting for phaophytin. The light comes in through here, and the sample is going to come into the sample here, and then the fluorescence will go out there and get the photodetector there. So you put the sample in to this container, and you always hold the sample by the top. Your finger grease will fluoresce. And we can set the sensitivity, which I won't talk about very much here right now. There's a coarse blank, so this is just no chlorophyll solution. So we use the coarse blank to set the 0, and actually I did pretty good there. I don't even need to use the fine blank. And then we just read all of our samples off in the machine. And the more chlorophyll there is, the more fluorescence. And if it's really high concentration of chlorophyll, then we'll use a dilution to get it on scale. This is a spectroradiometer, and we use it for chlorophyll analysis when the concentrations are high, and we also use it for when we do our nutrient analyses by hand. You can see that there's two cuvettes in here. One is the reference, and so that'll have the reference solution with no reagents, and then the other one is the sample cuvette. And we can use bigger cuvettes if we want to have a more sensitive machine. The way this machine works is that there's a splitter in here that is chopping the light between both sides, and so the detector is always comparing the baseline to whatever sample you have in there. And then there's also a monochromator, so you can change the wavelength of what light is coming through. So the light's produced back in here, comes back through here, and then the detector's here, and it'll detect that. So we can set whatever wavelength we want to use. We can scan a series of wavelengths if that's what we desire. When we use chlorophyll, we're going to have to phaophytin correct, so we would read the sample, acidify it to turn the chlorophyll into phaophytin, and then read it again to subtract that value out. We also have another addition here when we can semi-automate things. It's a sipper, so this cell is back in there, and this cell then has a little tube that comes out and a motor that'll pull a sample through it repeatedly. So the two things we've got for light measurement are fluorometer and the spectroradiometer. And this is the cuvettes that we use. You can see they're frosted on one side and clear on the other side. You want to clean off the outside with a Kim wipe or something before you put your sample in. There's not a sample in here, but when we put it in, we want to make sure that the clear side is such that the light will go through it, and the frosted side is there so we can pick it up out of the machine.
Alright, so we're going to do our samples, which we're going to do by... Walter mentioned that there's a reference cuvette that has DI in it back there. And then we're going to take this other cuvette that we hold by the frosted sides and fill it with our sample. So this is part of making our standard curve. This is a really low concentration standard. Perfect. And this is our sample to which the mixed molybdenate reagent has been added. We will put her in here. So is this. It's set to 885 nanometers. This is a 0 on our standard, so the absorption. And now we're going to do a higher concentration standard, so emptying out the sample just by dumping it into a beaker, not rinsing it, filling it with the next standard. Placing it in the spec, closing this, and we read that at that much higher concentration, the absorbance is much higher. by like 2 orders of magnitude. And we'll send you the data from those standards. So we are reading chlorophyll A, which we're first going to take this fluorometer and zero it out. We've put a test tube of ethanol in here. There's a window where light can go through here. Walter gave you an intro on this already. We are set to the 3x objective and are adjusting it to 0. We're getting the real experience.
Yeah.
Cool, so that is a nice 0. So now we're going to do this again with one of our samples. We took the tube that had the filter in it, where we had extracted the chlorophyll by submerging it in a known amount of ethanol. We then poured that sample into a test tube like so. Having just zeroed it with the ethanol, we're going to pop it in. And exciting. Yeah, that's a stable reading. Cool. So that's our value, and then we're going to use some standard curves and what we know about the amount of fluid that was filtered to get that filter, and the amount of ethanol we used to extract it, and the amount that we had to dilute this to get a readable sample interval, and we will be able to calculate the amount of chlorophyll, and we will send it to you. Cheers.